so that you can kickstart your reading. And the more you start early, A-level is the shortest time a student has in life compared to the other levels, where you have 4 years, you have 3 at the university or 4. Some of you want medicine, you'll have 5. Engineering, you'll have 4. So A-level has only 2 years, but you must cover a lot of work, so many papers, unlike S4, and each paper is so important. So I need that one book. The second book would be called A Concise Course in Advanced Level Statistics by Chambers. Though it's the standard book that the NCDS recommends, but it's very expensive. If you try to restock, the last time I tried its cost, it was over around 80 or 100,000. In case you can't afford that book, and this challenge is only for statistics, and yet we are talking about numerical and the others. Now, one of the common books that you'll ask that your teachers used, including Mr. Stendhal and Byman and the others that handle you, is my book, one of my pamphlets. It has 3 versions. The first version would be this one. I don't know if you ask your sisters, they could have used this one. It's one I wrote in 2002, Statistics and Numerical Methods. Now, around 2008, I improved it to this level, including a lot of flowcharts. Now, currently, the books have been out of stock, but last year, I used the lockdown to have what I would call the best version. So if you can get this book, it will guide a lot in your reading. There are a lot of exercises, a lot of questions, and my students have said it has been very good. So this was a book written by me. This is the latest edition. So those who can afford, you'll talk to Mr. Sendaula. When you get the resources, you can have it. Most schools use it. Then that's the other book. The other third book you need is Question Book Bank. At A-level, we don't keep questions for mocks and the others. An S5 must start researching, attempting questions per topic learned. If we met like thrice, I expect you to be in position to answer a full question in either last year's paper or in a paper. If had about 3 or 4 meetings. If you can meet for this month of September, sorry, you should be in position to pick numbers of the first topic from this book. So I hope some of you already have that. It has both paper 2 and paper 1. Then lastly, the other book you need is what we call a logbook. With statistics, a logbook is very useful. There are many logbooks, but the common one used is by UNEB. It has UNEB tables. You used it in senior 4. That book can be used from senior 4, senior 6, even sometimes up the university. Some students at the university, they still need statistics, and you have to use with statistics. The logbook has tables at the back. But those who have my book, at its back, I put some required, those specifically for statistics. I didn't put those for pure, but the last pages, they have the tables you need for statistics. But if you need a complete book with all the pure concepts also included, the formula and the others, you need to buy yourself a logbook. So those are the basic books. Lastly, we need a calculator. We have quality calculators. At A-level, a quality calculator can give you some advantage over the others, depending, because some of them can compare your integration. A lot of statistics is embedded. So you can use your calculator to work out, give answers to some numbers. Though sometimes some of you overuse them and you learn into trouble. So carefully, a student can take an advantage of a calculator to compare your answers. So a calculator should be given time. In other countries, calculators are even given special time on a timetable. And somebody comes for an hour to go through how to use a calculator. Now, in our country, and our MBs and that time may not be available for us to now start talking about a calculator. So you learn somehow in a manual way. Shall not give you a lot of time, but you need a quality one, probably FX 100M. Is it 100 MS? There's 991, 82. The one for 82 is good, but may not good enough. It will not do a lot of stat work. It will do the simple mathematics, but when I want you to do normal distribution and others, you'll be using your neighbors. So those are the basic requirements. Hope we are clear on that before you go into the discussion. Martha, are we okay with that? Since we've made that introduction, knowing who is going to handle this part, now somebody says, good morning, teacher. This is Ramla. I'm requesting you your number, please. My telephone number, can you write 0772 42 9998? But I can write it, I'll write it on the board. Let me go and share my board, my whiteboard. I'll share my board. And I hope you'll tell me if you can see what we write. So my number, I don't want to write the name again, but I can write for people. So if that's my name, those who came late. Now people said what they need next. I'm a teacher by profession for over, if Ramra, you are 18 years, I've taught for over 18 years, isn't it? So I'm a bit, you are my children, most of you. My contact, you'll use this. That's the main one I used. It has some WhatsApp, though sometimes you might find it hard to get me, but once in a while we can discuss a few things. So I think basically that's what we want from me, isn't it? The contact is shared. Now, if you are to talk about statistics, who can remind ourselves about stat? What is statistics? If we are to define, what do you call statistics? From your senior, because today I said you want what to cover, shall not cover so many. Probably this time we have for the holiday could be for 1 or 2 topics. So probably I introduce only statistics. Then I introduce chapter 1, which will have what you call statistics. So who knows, Cynthia, can you define for us what you call statistics in S2? What is statistics?
Statistics is the interpretation of data.
Statistics is the interpretation of data. That is great. That's very good. That's Cynthia. You have a very good start. Let me see, Abdul Noor. What do you call statistics?
This is the gathering of data about a certain group.
Repeat.
This is the gathering of data about a certain group.
Okay.
This is the gathering of data about a certain group.
About a certain group. We are very grateful. Thanks for your contribution. Do we have one more before we can share what? Let's Ramra. I can see, since I brought the board now, I cannot see everybody. Ramra, Nansubuga, what do you know about statistics? We've seen interpretation from Cynthia, gathering of data, very good. And lastly, one more person.
Teacher, statistics is the collection and analysis of data.
Thanks. Another one has given us, has added, there is collection which Abdul brought. Now she has added analysis. So when you combine those, yeah?
Statistics is a branch of mathematics dealing with the collection, analysis, interpretation, and presentation of masses of numerical data.
Good. So what's your name?
Arifin Abdurrahman.
Abdurrahman. So Abdurrahman, thanks. And the others, Naramra and Cynthia and Abdul. That when you combine the four, probably Abdurrahman finalized. So we say statistics is a branch of mathematics that deals with collecting. There is collecting. We have presentation. I think most of us were missing the presentation. You collect, then there is presentation, there is interpretation, and there is analysis of data. So we have those four terms, but I'll pick out the last word, which we are going to discuss a lot, this word data. So if you're taking note, statistics has to do with, the data. That's how do we collect data? Like for instance, I've already picked your data. I have four names. There is Abdul Nur, Cynthia, Nansubuga, then Abdurrahman, and the others. So already my laptop has given me some data. The names, that's data. So we've collected. So we can ask Ramla to give us more data about herself. Can ask what's her school, what's her combination, what's her age, is she married, does she have a boyfriend, is she a single girl, a single mother, all that becomes data. That okay? So statistics is a branch of math that deals with collection, presentation, interpretation, and analysis of numerical data, or we just say data. That's very important. We need to remember that. And the beauty of statistics, it cuts across all fields, whether you're a lawyer, whether you're a doctor, whether you're a social scientist, whether you are an engineer, a statistician, an askari, security, a banker. Statistics cuts across all fields in this life. There is no field that doesn't talk about statistics, or there is no business that does not talk about statistics. So that's its beauty. That's why it's taught as low as primary, so that by the time you drop out in P7, you have some basic statistics. You know the mean, age, and the rest. Now, I picked out data. I hope people noted there four, because I'm not going to give the notes. We shall probably write on the board the calculation. So all of us have clear about the four words: collection, interpretation, presentation, and analysis. So our major discussion in some topics are going to be about those. The first topic is about collection and presentation and some analysis. Then other topics will come for statistical inference and the others. Then we include some probability, because probability is very, very useful. So we call this work statistics and probability. And since also probability is total as low as P7. Now, what's data? That's our next now. After defining SAT, I want what's data? Who can define for us the word data? Quickly. If I use my brain, what's data? Let me see. I pick who? Which other name can't I see? I saw the people out. Martha has not said anything, so I saw Irene. Irene, Martha.
Yes, teacher.
Can you tell us what you know about the word data? By data on your phone. What's data? Data or data? What's it?
Teacher, I think they are raw facts and figures.
You repeat? Data is?
Unprocessed information.
Thanks. So we shall keep it short. Data is unprocessed information. Data are facts or figures collected for purpose. So many books have different, depending on which field. Like what she has given us is very true. Figures, for us mathematicians, we think data are figures and facts collect for a given purpose. Is that okay? That's why I said start. The gender ministry was the other time collecting data for people who are very needy, vulnerable. They highlighted different groups. Hope some of you didn't receive that money. Did you receive the 100,000, Martha? You didn't. You're not vulnerable, isn't it? Now, that after the definition, why I put for you two branches here, data has two forms. Either data is you can divide data into two. Statistical data. There's what we call quantitative, quantity. You know the word quantity? Data can be quantitative.
Teacher,
These are very critical things. Yeah.
I beg your pardon on what is data.
Speak, I can't hear from you.
I beg your pardon on what is data. The definition.
Data refers to facts and figures collected for a given purpose. Data refers to facts and figures collected for a purpose. Are you okay with that?
Yes, teacher.
Now, data can be categorized into two. Data can be categorized into two. We have data we call quantitative, and you have data we call qualitative, from the word quality, qualitative. We have qualitative. So you have data we call, I can use blue, you have what you call, we have qualitative and we have quantitative. Have we heard about those two words?
Yes, teacher.
Okay, so what is quality? What's qualitative in math? What's qualitative? Quickly, our time is running, and I wanted us to end with graphs in the 1 hour we have. So these definitions, I want us to remind us they're very, very important, but we need to. So who knows qualitative? You put up your hand and you tell us. Either you know quantitative or qualitative. Okay, save time. Quantitative are where we measure numerical quantity, numerals. Here we measure numerical quantity. numerical quantity. For example, how many are we in this class? I can see we are 28. So you can't, so it's a quantity, it's a numeral. How many are we? Right now we are 28 in class. That's a quantity, a numerical, isn't it? It's a numerical value. You can ask how many are you at home? Cynthia, how old are you? Girls don't want always to give their age, but Abdurrahman, how old are you?
I'm 17.
Yeah, 17. So when you say you're 17, Ramra, how old are you? Ramra doesn't know. Ramra, are you off?
No,
Who wants to
teacher.
tell us how old she is? What's your age? Are you 12?
No, I'm 8. No, 17. Sorry.
You are 17. Okay, Cynthia, what's your height? What's your height in meters?
5.5.
Yeah, what's your 5.5 feet, isn't it? You can even count on points. I wanted you to give it 5.5 is around 1.65 meters, around that. So we can give our height in meters or in centimeters, whatever. So when you give height, you give your weight. These are numerical values. So the number of children your father has, the number of whatever things you want, the amount of money you spend on data, all these are numerical quantities. Now that's what we call quantitative data. Now on the other hand, people in the arts, for you now, your discussion is going to start, namely dwells a lot on quantitative. Our discussion will be basically that side, quantitative data. Though qualitative is what the other side handles, the lawyers, they do a lot of qualitative work. So qualitative work, we say, measures attributes. This one measures what we call we use the word attributes. You measure attributes like being, like now Ramra is female, yet I expect Abdurrahman to be male. That is qualitative, those are qualitative things. We may not measure how female Ramra is. It's very difficult. So when you say, some of you say, Ateso. So the Atesos is the most powerful tribe. Those are, we call them attributes. Or the other one, where we come to attributes. So these things may not discuss them here. Religion. Some of you say, that girl, I thought she was very religious. Now, these are very difficult things to measure. Things that we don't measure directly, such as the sex of a person, how female, how male you are, the religion, the tribe, the faith, the color. Some of us are black. Some of you girls get annoyed and you bleach yourself because you want to become light-skinned. That is a qualitative measure. God made you light-skinned or made you dark-skinned, isn't it? So you don't start thinking being black is, you are below a certain level, isn't it? So when you measure things to do with these qualitative measures attributes, and this is a discussion that is common in people in the arts. They can drill on that and even try to discuss in detail. So our discussion here won't go into this. You just know the definition and we stop it for now. We shall not go into detail. So my discussion is going to dwell more on this side, surrounding the discussion of quantitative side. Is that okay? Now I want you, the forms, if we now concentrate on the quantitative, what are the forms of quantitative? Is our next discussion. So are you okay with these two? We are done with the qualitative and quantitative. Ramna, is that okay?
Yes, teacher.
Now, if we're using Google, we do keep our boards and even check them later. Now the problem with the Zoom, I need to clean the board. They don't give me another clean board easily. Though they're very good concepts to use. So if we are now under quantitative, also quantitative data can also have two forms, can be divided into two in the discussion. So topics of these statistics are divided into two. There is what we call discrete work, and there's what we call continuous. Have you heard about these two words? Abdurrahman.
Yes, sir.
Yeah, so either data is discrete or your data is continuous. Now it's very, very critical for students to understand these two. And as long as a number indirectly in trying to distinguish the two, and some students, that's why you see there are many A's and there are many, I saw people, some school with many F's, with the equivalent number of A's as many as 70 A's, but as many as 20 F's. That's a big number. If you understand these two words from the word go, they're going to categorize all our topics are either discrete or our topics are continuous. So we categorize statistics data into two. So who knows the word discrete? Quickly. Let's see, want somebody outside Rahman, Cynthia, and let me first close my soul so that I can see other people online. Let me see. Angela, can we have Angela?
Yes, teacher.
Angela, can you tell us what does the word discrete mean? You had the word discrete in your, I think, senior too.
I think.
No, you didn't. Probably so. You think?
I think discrete data is data that cannot be
discrete?
expressed in integral values. I think discrete data is data that can only be.
We are losing, use it my network. Okay, let me first mute myself. Come again as I.
In terms of integral values.
So data that can. You okay?
Data is data that can only be expressed in terms of integral.
Teacher, you're muted.
Sorry. Things that we count, we get by counting is discrete. Things that we get by counting is what? is discrete. Then continuous is the reverse, things that can take on a range of values, even including the decimal and so on, is continuous. So for continuous, you're talking about it takes on any value. Takes on any value. That is continuous. Any value. So it should be in position divide, put things here and there. So the common continuous things that you can talk about is like our height is supposed to be continuous. Our marks, actually, when you get to the university, you'll know marks are not discrete. You complain with marks at school, but marks you realize when you get it to campus or chemistry, practicals, and others. Marks are supposed to be continuous, but for you count them in whole number form. But at the university, or those who are in senior 6 VAC know now the weight for their course is an example. You can say you missed a course by 0 point something. So weight is continuous, hourly weight, time, the time we take to do things, time in terms of hours, minutes, and the rest, years. Like some of you are celebrating your birthday, but the time has changed. You could have been born at 7 a.m., but you celebrate it in the evening. So that exact time is continuous. Temperature. Temperature. Those who are in physics, velocity, acceleration, impulse, most of the things we have in life are continuous. Weight, time, distance, the distance you move. Some of you like me, your network is not good. You have to climb a tree. You have to walk to the next center. You have to go to your auntie's place. She has a good laptop and good network in the place, isn't it? So distance covered, acceleration, velocity, whatever. So many quantities are called, they are continuous. Now the others that remain we count, like now our number here is counting number of people, 27 is counting. Okay? Now the things vary. Some of them we can put age here. In Africa, we make age discrete. When they say, how old are you? You say, some of you said 17, but you are 17.2. So that's why some of them cut across. I can put age here, and that, though genuinely, age is time, should have been on the continuous side. So age, number of sisters, number of brothers, number of meals you have, number of things, the number of cars that your father has, number of bajajes, number of books. When you're talking about number of items, we call that discrete. So it's counting things. Now, this is very critical when we are discussing statistics. It will determine, it's important how you form your groups and the rest. So once that is done, the only remaining concept that probably I wanted also to mention is what we call a quantitative variable. So a quantity is something that we measure, we count, and it's called a variable. So this word, in addition, before we go into the, because people might say, we're only defining, when shall we write some mathematics? We need these terms to get to us. Variable. A variable is something we count or that is counted or measured. When I ask for your height, that height becomes a variable. When I ask for your mark, that what was your score in your O-level mathematics, and Ramla says D2, that becomes a variable. Is that okay? So a variable is something you measure or you count. Your age, your mark, whatever we say can be a variable. Now, once we have those, the rest they will come on board because there is crude data, raw data, and the rest, population, samples, those will come, but basically I wanted us to be clear on those two words. From definition of statistics, collecting, presentation, interpretation, and analysis, then of data. Data are facts or figures taken for purpose. Data can be categorized into two, qualitative and quantitative. Then we discuss more quantitative than qualitative issues. And under quantitative, we categorize into two, discrete and continuous. So our topics in statistics, if I at least want to cover, I just put topics this way and other topics this way. But since you've not covered much, I may not give you those topics because you won't. But as you go on, you realize when your teachers are defining topics, they'll say this normal distribution is continuous. Binomial is discrete. So there are topics in math, we say there is binomial, there is what, and so on. They're divided according to these two powerful terms. Now, I want us to go quickly to the senior two work we did before we pick the graph quickly. Before we pick our graph paper to draw some graph. Because what I want us now to do, since we know the S2, now I want us to pick out one. So we already know, we know frequency. Is there anybody who doesn't know what frequency is? Abdurrahman, do you know frequency?
Yes, sir.
Okay, good. So we don't need to discuss frequency. Because here you can even generate, say the boys put up your hands, the girls, and that will be frequency. You can say boys, this number, girls, that number. So the number of times an item occurs is frequency. So that was covered in S2. Now another one, I think under grouped work, let me give some example here. Let me say, if I picked, let me give this as the weight for the class. Now, because of time, I won't give. My things are on the problem now with the laptops. Let me first share the screen. Let me first. My board has misbehaved. I wanted to move this. So I was giving you the weight and the frequency. So quickly, I'm going to assume you are this number. But let me say, I have people here, like girls who want to be small. So I could give you these classes. So I want to use this quickly to remind ourselves. As I said, in statistics, we revise a lot of our senior two work. And you open last year's paper. I don't know if I carried one, but if you check last year's paper, you might find a similar number. You say, now a number in senior 4 paper appears in senior 6, but we change a few things. Now, not this count, this one doesn't exist, that one, okay. The problem with my natural board has some things, it can disappear at any time. So I have 3, 10, 16, 10, and 4. So this is We agree this is grouped data, isn't it? Ramna, is that okay? So I want us quickly to revise this before we go into our discussion. Cynthia, we know what you call classes.
Yes, teacher.
Yeah, so the first column here is representing the classes for the weight. 40 to 44 is a class. So I can pick something here. If I picked a class of 55 to 59, using now our A-level knowledge, who can give me the class width? What's the class width? What's the class width? Abdul, Angela, what's the class width?
5.
So I hope people know that it's 5. So since how did you get 5?
I got 5 by subtracting 59.5 minus 54.5.
Okay, you see, so she has brought in some other thing. She's talking about 59.5 and 50, probably let me write that. 54.5 to 59.5. Okay, so Ramram, what do you call those? So what do we call, Angela, no, Angela, what do we call that? The 54.5 to 59.5.
Class boundary.
Yeah, we call them class. So we call the, okay, class boundaries. So that these terms that some people get disturbed. We have class boundaries. Whereas this one, we could call them class limits. Some books will allow it to call 55 to 54, 59. It's a class, but it has class limits, lower class limit and upper class limit. Now this one has class boundaries, lower class boundary and upper class boundary. Now this is a very simple thing, but disturbs some of you. So if you want to get the class size or class width, we subtract this minus that. But there are many alternatives. Others basically look here. So since you're 55 minus 50 gives you the 5, or 59 minus 54. If the classes are the same, but that works only if the class size is the same. Once the class size is the same, you just use 45 minus 40, 50 minus 45. That will be the class size if the classes are the same. And that's common at S4. Here at A level, this topic is very common because they always set for people different classes. Now, Master, give us the class 55 to 59. Quickly, because my time is running out before even I start the presentation, which is our major discussion today. Martha, are you still with us? We pick who? There was the other, I forgot. I have seen here, there is Abdul Rahman. What's the class mark? Abdul Rahman, what's the class mark?
So you meaning the upper class boundary?
No, there is the median mark for this class 55 to 59. Do you remember that?
No, sir.
You don't. So that one is obtained by adding. You add 55 plus 59 divided by 2. What you get, we call it the what? The class mark or the median mark. So all these classes, they are represented by a class mark. So when you are 40 to 44, your weight becomes 42 in term. That's why in books they will say estimate the mean, because what is used is a general class mark, it may not be the exact weight for that person. It's 51. What do we get? Do we get 57? Is that okay?
Yes, teacher.
Yes. So we should now get those basic things. If we have those, very, very critical. But we should take note. Here I've used a very easy example for senior 4 or level senior 2. But if we would change this and put here, there is a year they put here, instead of that, we change this to something different. If we can change this to, let me say, something like an earthquake. If like the hurricanes, they are measured in terms of what in a Richter scale of 0 to 10. So some earthquakes, they hit at levels, like, let me say they can start, you have strong ones, 7.0 to 7.4, 7.5 to 7.9, 8.0 to 8.4, 8.5 to 8.9. Now there, I want us to answer the same things. If I remove now this one, and this, and that. So I want us to, the problem with the board for Zoom on the computer, you have to clean. That's why sometimes people use Google with their continuous board, which remains. So when you go to the university, they will be using other boards where we don't need to clean. So here, if I pick for your class, like 7.5 to 7.9, and answer the same questions, who can tell us, Namra, what's the class width? Now, what's the class width? Somebody give me the class width.
0.5.
Quickly. Anybody?
0.5.
Abdul. This see, the class width becomes 0.5. This is the difference. So in SO people are used to 510, 510. Now here, these are common questions at A level. But basically what you can do, I basically picked 7.5 minus 7.0. That will be your class width. Now, with that in mind, can we pick out and write out the class boundaries for one of the classes? If I wanted to write the class boundary now for this from 7, I want us to write that. Who can give me the class boundaries now? If that's the class width. Who knows the class boundaries now for this? Cynthia.
6.5.
You have 6.5?
6.95.
6.95. How did you get it? How did you get that?
I subtract 0.05.
You subtracted 0.05.
0.05.
Yeah, 0. So you subtract. So the lower class boundary, you'll subtract 0.05, isn't it? Let me first clean this and see. I think we know that word. That's what we need. What do we get? So you do the subtraction because you don't get 6. You get 6. Do you have your calculator? What do you get? What do you get?
7.45.
So I expect you to say 7.45. So some of you, when you just use your mind, you give a wrong answer because they will subtract either one, and you give 6. Yet now here, the lower class boundary is 7.45, and the upper is 7.95. You see, I've added a 5 here. You subtract it 0.05, you add 0.05. So are you okay with this? So at A level, this is very critical on knowing how to get it. Then the class mark. Who can give us the class mark? What's the class mark now, or the median mark? Abdul, what happened? You disappeared. You started, some of you, I'm told you start and then you go away and you watch cartoons. What's the class mark?
8.2.
You've got?
8.2.
8.2. How did you get that? Remind us, what did you do?
8.0 plus
I want
8.
for this, no, want this one for 7.5 to 7.9. We're using this one.
Okay.
So the one for 7.5 to 7.9.
7.7.
Yeah, we have 7.7. So I hope members are following. You add 7.5 plus 7.9 divided by 2, and you get 0.7. Even your 8 was okay. If you had picked 8.0, it's 8.2. That is very important. Now, all those examples are discrete. All those examples have given you discrete work, but I can make it continuous at A level. If I want, I can make this continuous and even make it a bit more slightly different. If I can come, if we can come and now change. I was cleaning. I want us to, I can change something here, which is very common. If you open any question book bank, you'll see questions that have different things. Anybody there with a question book bank? And I see, I can come and pick from a question book bank. That's why I told you these things are very, very important. You might see a question, though the one I have is a bit old, may not have the thing I want. They have, don't let me give one, the discrete one. I can give you one more where the classes are different. Like in 2017 here, they gave them, let me give you this one before I go to the other one. Because if we pick this from the one go, then we won't have problems with the statistics. Because some of you say questions are easy, but I failed them. Why? Because so they gave them time. They gave them time and frequency. So the students, I think, were going for lunch, and they were saying that some boys go for lunch, and within 3 to 4 minutes, the boy is done. So there were 2. Then another group, 5 to 9. These were 7. Then you find other boys, 10 to, the boys will take less time for lunch because they want to go and run and play some football. But now the girls, Ramra, you know the girls from Nabisusa and many girls, they walk. They don't want to run even when it rains. Isn't it? Ramra, do you run when it rains?
No, teacher.
Yeah, you don't run. So you end up taking a lot of time. So you might take 40 minutes for lunch. You cannot do an exercise during lunch time. Now, that year, if you check, This is 2017, number 12. Those who have a question book bank. 2017, paper 2. 2017, number 12, isn't it? What they want there is, by today, if we are serious, I should have reached this level. They want us to draw an histogram. They want us to draw what? An histogram. So we are going to talk about that presentation. But what I wanted, before you go into the histogram for today is, can we now determine the class size? So I can introduce, see, here, if you are going to do the histogram, you need to know the class size for each of these classes. Or before even the C, you need to know the class boundaries. The class what? Boundaries. So I hope you are writing. Can you write with me so that you also have, can we come up with a class boundaries now? And once you have the class boundaries, then you can easily draw what you call the histogram. So if you check this, you start with the class boundaries. That since this is discrete data, this class is 2.5 to 4.5. If we use what either Ramlo or Cynthia gave us. You see that? Are we there?
Yes, sir.
Ramla, is that okay? Therefore, this one is 4.5. This one is 9.5. Then this is 9.5 to 19.5. This one is 19.5 to 29.5. And the last one is 29.5 to 44.5. Is that okay?
Yes, teacher.
Now, so unlike the one for S4, where the classes are the same, I'll put C represents class size. What's the class width here? What's the class?
4.5
minus 2.5, isn't it?
to 9.5.
So what's the class width here? We say it's 2. Do you see that? So 4.5 minus 2.5, the class width is 2. Is that okay?
Yes.
Which I said you could say 5 minus 3 and you get the 2. Now, what about here? What about this one? Then I want somebody to give us the class width here. 9.5 minus 4.5, what do we get?
5.
5.
So can we write? I want you to write those figures. And this is 5. What about this one? Who has the answer for the next one? You unmute and you speak. Next one?
10.
10.
This is 10. So do you see how HS changes? If you go through all your O-level papers, you won't find a paper like this. That will be an impossible number that year. Because all your numbers in S4 that you did of statistics, mainly they don't change the class size. They give you the same class size. Yet in your life, these things happen. Now, when you come to this one, what do we get? This other one here right now, 20 to 29. You see that we have 10?
Yes.
And then the last one, what do we have?
15.
Last one is 15. Now, that when they set such a question, probably I can, because our discussion before we conclude is supposed to be, I want us to draw graphs. But right now you cannot draw this graph. Once, the first thing before you talk about drawing a histogram, if you want to draw a histogram, the first question you ask yourself, are the classes the same? The classes must be what? The same. Now, one homework you're going to do, I want us in our discussion, so people to come up with this histogram when the classes are different. But I can give you a clue. what do we do? If you want to determine to draw a histogram, I hope you know what you call a histogram. I'll go back to it, but I hope we know, isn't it? Ramla, we know histogram.
Yes, teacher.
Okay. Now, a histogram at HS has many different ways. One of them, I'll call you in a meeting. Hello? I'll call you in a class. So we're going to have another term very soon called frequency density. So if you are going to do this, Ramla and others in your free time, if you want to draw a histogram, you must be having a graph paper, you must be good at scale, and two, you look for what we call frequency density. So note somewhere, frequency density is equal to frequency over class size. So if you're going to draw a histogram for this one, we shall need frequency density. So here, in your free time, you calculate the frequency density, then probably when I talk about presentation, you'll do that graph. I hope you'll try, but you shall need. So the first entry will be 2/2 shall be 1, then the next 1.4, and then you'll complete. So I wanted us to get that. Now, those three examples I've given are for what we call discrete data. If you understand the word discrete, this is an example of discrete, because you'll have the 2.5 and the rest. But you might find other years, we have things that are different. You're going to have things that are like this. So Ramla, have we taken note of that? And others? Have we taken note of that?
Yes, teacher.
Okay, now, quickly, I want to give examples of continuous, because this was discrete. Let me transform the same example into something continuous. Let me try it. So before you draw any graph, you must check whether your work is discrete or your work is continuous. So now, if I'm to give, let me also remove time. I'll use max. Now I want to give two examples here that if you check even in the past paper, you might even find them in submath. Is there the number was set in submath, and let's say I can put here max. They do max, then they put for them. You'll find in most cases the right. I can start with this. When you find questions that are like this, when questions are written like this, I'll start with the one for submath as an example. Some of you look at submath and even you don't want to help them. Yet some years, you might find a number from submath is similar to your number, even in terms of, let me pick these at random. So now, this is another example of the other three examples were discrete, things we count. Now, when an examiner gives you something like that, if you check your question book back, you'll see them 2014, 21. They are similar questions, something like that. We call that work continuous. It's no longer discrete. We call it. So this is another area which is very different from O level. So first thing you do, Cynthia and others, first look for the class size. But when you're doing this, don't introduce other class boundaries. What you have here, we already call them now boundaries. Once you find that there is a 20 here and a 20, a 30 and a 30, 40 and 40, 50 and 50, it means that you already have what you call boundaries. So we don't call this discrete, we call this continuous. Even though there is a less than sign, that less than sign is similar to basketball and football. But who plays football? Is Nulu there? Girls. Ramana, do you Nafsa used to play football? Do you play football? Asime?
No, teacher.
You don't. Asime, who plays football? Ramana, mute. Asime, do you play football?
No, teacher.
Okay, but the boys, I think Abdurrahman should play football. Those who play football, there is when you say under 16. You know that under 16, somebody who is 16 plays?
Yes, sir.
Yeah, so that's something like we use as a content. So under 20 includes somebody who is 20. But most of you, when you see the less than sign, you take it as 19. In statistics, under 20 includes 20. Under 30 includes what? 30. So if you want the class width, you basically subtract 20 minus 10, and you write here 10. 30 minus 20. So you basically take these as already class boundaries. And even when you go to draw a histogram, there will be no 19.5. These are already the boundaries. Now that's how HS is different from O level. So if you want class boundaries, if I want to write them for you, there will be 10 to 20. You just write that. These classes, 20 to 30. 30 to 40. And to do statistics, that concept of continuous is very important, that you must know whether your example is continuous or discrete. Is that okay? Now, as we conclude, because now your assignment is going to be, you're going to draw for me graphs for this. And so lastly, I want to talk about histogram, and all these examples I've written about all the four. You're going to draw the histogram, and you must know which histogram are you going to draw. Is it for continuous or discrete? Is it equal size or not? So that's our last discussion in the little time we have. So I hope this is okay. So after that background, now let's go to the histogram. Since Ramra is our timekeeper and she told me we stop at 10 what? 10:30. We have a few minutes to conclude, isn't it? A few minutes to conclude. And the good thing already, the assignment you want to do, I've already given. But let me talk about the histogram itself. Now, I've picked out histogram for today, but under our definition of statistics, the ways, if you have my book in the book, ways of presenting data are many. They include bar charts, they include histogram, they include frequency polygon, ogive, pie charts, pictograms, and so many others. You saw them in S2. You saw pictograms in S2, pie chart in S2, frequency polygon, ogive, histogram, and the others. Now I picked means I only want to talk about histogram because the others are easier. I want to talk about histogram, but check any paper, even today's New Vision, you'll see a pie chart or a bar chart. We call those presentation of data. Data can be presented in either using a pie chart and so on. So How do you come up with a histogram? A histogram is obtained by plotting class frequencies versus class boundaries. Abraham, have we heard? A histogram is obtained by plotting class frequencies versus class boundaries in case the classes are equal. That only works if the classes are what? Of the same size. But once they have different size, we use class boundaries versus frequency density. That's why the last example of 2017 question 12, I talked about frequency density. So quickly, if you have your graph book, let's start with the first question, which had weight. Ramra, remind me of the figures for frequency. It had 40, 40, 40. This one. Do you remember this one? I don't remember the frequency values, but I can pick them from my book. 55, 59. The last one was 60 to 64, isn't it?
Yes, sir.
So the frequency values were 3, 10, 16, 10, and 4. So if we give in that and I say, draw an histogram, this is what you did in H4. So this one will be the easiest for you. So I said, so in your one of the graphs, I want this one. So basically get class boundaries. You'll get the class boundaries first for this, where you'll have 39.5 to 44.5. Then 44.5 to 49.5. Then 49.5 to 54.5. Then 54.5 to, since I hope this is okay. This is 59.5. So I'm showing you basically how the histogram will look like. So the most important thing when we are drawing graphs, why this question is important, if you read UNEB reports, you need good scale. You must have a good scale. You must label your vertical axis. You must label your horizontal axis. Is that okay? Then the bars should be well drawn, and you must use a graph paper. I didn't tell you, but I was an examiner for 18 years, so I know the basis how things are marked. I marked before you were born. Ramra, were you born by 2000? You're 17, so I marked from 2000 up to 2018. So graphs, you must have very careful about them. You must label the axis, the vertical, the horizontal. The scale must make sense. That's where students go wrong. So quickly, the 2 minutes we have, let's try and draw for people, so that in your free time, you draw the rest, the remaining. So you have this one, there's the other one which had 3 to 4, where you're going to draw a histogram with unequal class widths. Then the one for the classes that were, were continuous. And then I don't know if I have if you had last year's paper or the other one, we'll check for another one. But let's see only this and the, I create some histogram here for us as we close. And we give some things. So I can retain that as my title. Come here, pick my screen. So I want a histogram. I said you must have a graph paper. You don't use a board like me. Get a graph paper, draw a vertical line and a horizontal line using your graph paper. So label the horizontal line. Was those, I don't know what name I gave it, but you can call it like for you, I used, call it class boundaries. You can call it upper, all upper class boundaries. Most of you used to upper, but even class boundaries, okay? Then you put here frequency. So that's the first assignment. Label the horizontal, label the vertical. Then for starters, if you don't want trouble, start from here, the first value, put it there at the line itself, because some of you place it after and you collapse your scale. So the next value will be 44.5. So 49.5, 54.5, 59.5. I think that was our last is 64. So that's what I call, our scale is not like geography. We don't really say the scale is this in words. We just write on our graph and people will see. Then here I can come and I say, if this is 0, I can make this 2, 4, 6, 8, 10, 12, 14, and I think we're stopping at 16. Ramona, those are our figures.
Yes, teacher.
Yeah. So you're going to draw your graph. The first value, what's the first frequency?
3.
3. So we come and you get your pencil and draw that. Then the next is 10. What's the next value? Next figure is 10, isn't it?
Yes.
You need to be, so these bars connect. Then you have 16. Then finally, the last one was 4. Now, next time I'll show you PDF, share my graphs when they are really very, very clean and on a graph paper. So you're not supposed to use free papers. You must have graph paper. So I have scale, both vertical and horizontal. I've labeled the axis. I have these bars, they should be equal and corresponding height. Then I put title histogram. So in your free time, because now our time is done, look at the examples we gave. Those numbers, the 3 I gave, now I've done only 1. Draw the other graphs so that next time I'll allow you to share your graph and we see. You'll scan it or you can send it to my WhatsApp and we share your graphs for discussion.
Excuse me, sir.
So today, I think my time is done, unless you have a question.
Yes, sir.
Please speak. Said, who is that? Let me, okay. We go back to the class. Somebody wants to ask something.
So you said that
You speak.
for continuous values, for continuous values, we use class boundaries versus frequency density.
We say for continuous values when the class size is not equal. But for continuous values like the one I gave of 20 to 30, you still use frequency. You only need frequency density in either case, whether discrete or continuous, so long as the classes are different. So long as the class size is different, we shall need frequency density.
Thank you.
Like that number of 2017, the other numbers. That okay? Let me see 2016. No, we don't have time to check, but 2016, yeah, 2016, we have not discussed it, but 2016 is continuous and you'll need number 9 in 2016. If you can try it, number 9 in 2016, I want you to try it and shall discuss it. Still, you'll use frequency density, but the one I gave of 20 to 30, you use frequency. Have you got the difference? Hope I'm understood.
Yes, sir. Thank you.
Any other question before you're welcome? Any other question? Abdul Noor, Husna, the people have not said anything. Daniel, Daniel, is it Kezel or what? Becky, many people have not said anything. Probably next time. Any questions before because there could be somebody else waiting for you. Ramla told us 10:30. Angela, do you have any question? Asha, we have Asha. So we can stop there for today. We meet next week. If Mr. Sendal agrees and I get the time, meet next week, same time. Is that okay? Abdul, is that okay?
Yes. Yes.
Yeah, thanks also for being good listeners. Let's meet next time. Wish you all the best.